All right, logic. Lots of definitions initially. So if we have a statement, we denote it by a capital letter. So R, it is raining. S, it is sunny. And it's either true or false. Okay, so another mathematical statement would be this. X is less than or equal to 4, and you know that that means X is less than 4 or X is equal to 4. And this statement here is actually an and. So get familiar with those. All right, so when we want to say the negation, so we want to take the opposite of, we use this little symbol called tilde. So if we're given this statement, P is this, then not P would be the opposite, right? Okay, so now we're going to be doing lots of truth tables. So we're going to set up a table with P, and the options for P are true or false. Then we're going to set up a column for not P, and so if it was true, then we're going to make it false, and if it was false, we're going to make it true. Okay, that's negation. So a statement is either true or false, and then we take the negation of it, changes it from true to false or from false to true. Okay, so when we use and, sometimes we use the word but, and that's this statement, this notation here. So this statement right here is same as saying x's are greater than or equal to 1 and x's are less than or equal to 5. Okay, so we're talking about and, so let's talk about the truth table for and. So we have two things, right? We've got a P and a Q. So I want to start to give you helps or hints of how you want to draw up these truth tables. So when I've got two variables or two statements, I want to make the first column true, true, false, false. And I want to make the second column true, false, true, false. So this way will ensure that you have all combinations. So I'm really going to encourage you to make it this way. First column, true, true, false, false. Second column, true, false, true, false. Okay, so now we're going to do the conjunction, the and. So if true and true, we get true. Okay, so and means both have to be happening. If this is true and this is false, then this is not true. This is false. If this is false and this is true, no, it's not happening, so it's false. And if they're both false, they're false. So there's only one case for true, and that's when they're both true. They're both the same. Okay, so now we have the or. So we're going to be talking about P and Q and P or Q. Okay, so again, make this first column true, true, false, false, true, false, true, false. And now this means or. Is this true or this true? Yes, one of them is true. In fact, both of them are. Is this true or this true? Yes, one of them is true. Is this true or this true? Yes. This one is the only one that's false because there's no true. Okay, so here we get into a little bit different. So this is conditional. So spend a lot of time thinking about this. So we use this arrow, and it's really powerful. So it means P implies Q, or if P then Q, P is sufficient for Q, or Q is necessary for P. So this is the truth table that we're going to make. So P and Q. So again, true, true, false, false, and true, false, true, false. Okay, so the conditional statement. So spend some time on this because this is important. Well, I'm going to use the logic, or think of it as, if I show up on Monday, then I get the job. Okay, so this first row here. If I show up on Monday, then I get the job. Yes, that was the agreement. So that's true. If I show up on Monday, so row number 2 here, if I show up on Monday and I don't get the job, no, you broke the agreement. That was the agreement. If I showed up, I was to get the job, so that's false. This one, if I don't show up and I get the job, we call that vacuously true. You don't show up and you get the job, your uncle's the boss. You don't show up and you don't get the job, well, yeah, that's kind of how it works, right? So they're called vacuously true. Oh, that's spelled wrong, isn't it? Vacuously true. But this is very important. So spend some time thinking about this one.